Distance. How are you getting distance? Shouldn't we use something like sine or cosine, or shouldn't we? Don't you have this sort of feeling, right? Well, here's why you have that feeling is that that star, I'm going to draw a very exaggerated diagram because nobody can really conceive of how small that angle is, right? But let's assume that that's our angle. That's our 0.037 seconds, right? This distance here is our 1.5 times 10 to the 8th. Right? Isn't this the opposite side to the angle? And aren't what we're interested in the adjacent side? Right? Right? And so tangent, right, the tangent of phi is the opposite over the adjacent. So to get the adjacent, we just take the opposite side, which is this, and divide by the tangent, right? So the adjacent is 1.5 times 10 to the 8th meters divided by the tangent of, and now we've got to make it into, this thing is definitely going to be in degrees, right? So I have to make this thing the tangent of 0.037 divided by 3600 to actually feed degrees in there. Isn't that right? Right. So the 0.037 is a small part of an arc second, which is just a small part of a degree, right? So let's go 1.5 times 10 to the 8th kilometers divided by, and let me make sure that I'm in radians. Got to be in degrees, enter. Okay, clear. Okay, divided by the tangent of 0.037 divided by 3600. And I get, my answer is about 8.3 times 10 to the 14th meters. Yeah? Isn't that wild? So it's the same thing. The reason why you can just go 1 over the angle and you don't have to do like the tangent and all this stuff, right, is that all of these trig functions, when you get to such small angles, just become straight lines. And that's because if you think about sine, for example, so the sine is really like this wave like this. But if you zoom way in on that, way in, basically it looks like this when you zoom all the way into it. It's just like it's a straight line, isn't it? Y equals x or something like that, right? So sine x becomes x at small angles, right? But anyway, this is what I kind of expect you to understand. Not so much this, just that this really does work for really small angles, okay? The other thing that you need to understand is that we can't find parallaxes for stars that are really far away, right? So if they're like more than, I don't know, like 1,000 light years or something like that away, or 10,000 or something like that, for sure, we can't measure the parallax, right? So these are all pretty close stars in kind of our neighborhood that we can do this for, right? So that's 1 unit, right, is a parsec. And let's write that up here. There's a formula for it, right? And then let's write, and I think you've got this in your note guide, right? But 1 parsec is 3.086 times 10 to the 13th kilometers, right? I'm just going to hit the right arrow because now we need to get to light years. And a light year is the speed of light. It's the distance that light travels in a year. We are only, by the way, 8 light minutes from the sun. So we're not seeing the sun as it is now. We're seeing as it was 8 minutes ago, et cetera, right? Okay. So you take the speed of light, you take a year, days in a year. There's a little more than 365, right? 24 hours a day, 3,600 seconds per hour. And you get something that is like 9.46 times 10 to the 12th kilometers. Right, and these guys are in the ballpark. So 1 light year, right, is 9.46 times 10 to the 12th kilometers, which is approximately equal to about 10 to the 13th kilometers, right? So if you're subtracting, if you're doing like rough math, you can just say it's about 10 to the 13th, right? This should be an approximately equal. I don't know why it says equals, but it's not. Okay, and I think we got some whiteboards all together. Oh, and then this is kind of cool that these 2 major units, a parsec and a light year, are really close to each other. 1 parsec is actually 3.26 light years. That's kind of cool, isn't it cool? I don't know. Physically possible for people or a large object to get there. Yeah, eventually, I mean, there's no reason you can get very, very close to it. You just can't go faster then, right? Particles, for sure. We've got particles that are going essentially the speed of light. right? Particles, we just have this big ring and we just speed them up as they go around and around and around and around.
Man fly at that speed.
The what?
I mean, like man fly at that speed.
Right. That would be hard.
You'd probably be doing it all.
Yeah. Let's try this one. Our galaxy is 100,000 light years side to side. So how many meters is that? It's a lot. Hey, can we not do that? Yeah. Oh, no. You can have it. Hundred thousand, isn't that 10 to the fifth?
Yeah.
Yeah? So what's 10 to the fifth times 9.46 times 10 to the 12th? Is it 9.46 times 10 to the 17th?
Yeah.
Is it that simple?
Yes. Could be. No.
If you multiply numbers...
10 to the 20.
Hmm? Oh, meters, right, because that was kilometers. There you go. Got to add 3. Yeah, you got it. So you want to multiply 100,000 by this, and then, of course, don't forget that that's kilometers, and you want meters. Yeah, put what units does that have? There you go. That was the whole point of the whole thing. And that's kilometers that you just figured out. So how many meters? That's right. I did the same thing. So don't, that's right. And that's kilometers. How many meters? Hey! Yes? What are they doing in that class? Tip it. I can't see it. There's glare. There you go. 18, is that 18?
Yeah.
I get like to the 20th or something, or the 70s. Is that a 2-0? What units? That's right. The right units? No, that's... There they are, yeah. Yeah, you got it. Yeah. Is that a 2-0? Your 0 looks like it wants to be a 6. I don't know. Yeah. What?
Why did I get to the 17?
Because you have kilometers and you need to multiply by 1,000.